If a divisor divides a polynomial with no remainder, then the quotient and divisor can be multiplied to form the original polynomial. This means that through division we are able to find another factor to go along with the divisor, and from there find any remaining zeros. This is known as the factor theorem. Example 6, we have a polynomial equation, 2x cubed minus 3x squared minus 11x plus 6 equals 0. Given that 3 is a 0, find the remaining solutions for this. Okay, so what we want to do, since 3 is a 0, that means that x minus 3 is a factor of the polynomial. So if I divide my polynomial by x minus 3, the divisor I get will be a second factor to go with x minus 3. Again, where did I get x minus 3 from? I'm told x equals 3 is a 0. So if you subtract 3, you get x minus 3, and that's a factor then. So our process is divide this by x minus 3. Our divisor is another factor, and using that other factor, we can find the remaining zeros. Notice, if you tried to do some factoring by grouping like we have in the past on this, you will not be able to factor this by grouping. So this is really the only way to find the exact solutions of this. So we want to set up a synthetic division with 2x cubed minus 3x squared minus 11x and plus 6 with our 0, 3 outside. Do a synthetic division. This is going to lead us to a second factor. Bring down the 2. 3 times 2 is 6. Negative 3 plus 6 is 3. 3 times 3 is 9. Negative 11 plus 9 is negative 2. 3 times negative 2 is negative 6. 6 minus 6, remainder 0. Okay, make a note that if you're given a 0, or if you know something is a 0, then your remainder had better be 0. Okay, otherwise your division did not work correctly. Our polynomial was 2x cubed, so our divisor should start, or sorry, our quotient should start with x squared. 2x squared plus 3x minus 2. So there's our quotient, and what that tells me then is that this polynomial factors into x minus 3 times 2x squared plus 3x minus 2. And we're figuring out, when does this equal 0? Well, we know this gives us 3, and this polynomial, we can either try to factor it or use the quadratic formula. Now, oftentimes, this will not factor, so I'd recommend probably using the quadratic formula for these problems. So we'll say our other solutions, x equals, from the quadratic formula, opposite of b, plus and minus the square root of b squared minus 4 times a times c all over 2a. Okay, underneath the square root, we will have 9, and then plus 16 is 25, all over 4. And 25 is a perfect square, so we'll get 2 nice integer answers for this problem, okay, or possibly nice fractions. So again, we had negative 3 plus and minus the square root of 25 over 4 on our last sheet. Square root of 25 is 5. And so now we want to split this up into our plus and our minus separately. Negative 3 plus 5 is 2 over 4, and that's 1/2. Negative 3 minus 5 is negative 8 over 4, and that's negative 2. So there's our 2 remaining solutions to go along with 3. So our solutions to this polynomial equation, we want to include the number they gave us, 3, and then we also have 1/2 and -2 in no particular order.